Hello and welcome back. Let's try to continue our program of soil mechanics. We are still on chapter number 5, which we are trying to complete with this video. So, classification of soil. By the end of this video, you will be able to classify any type of soil according to any classification system, or let's say mainly with AASHTO system and unified classification system. So this video, we will do some example, maybe 2 examples on the unified classification system, unified soil classification system. Okay, because this fifth point is the one we worked on last time in the previous video. So this video we will just do 2 examples on this system, and then we go to the last point, which is comparison between the AASHTO system and unified system. Okay, so this video will focus on these 2 points. Sorry, not this one. This one, unified classification system examples. So the first example, the first example is telling us that this is the result of particle size analysis of soil. This result is telling us that the percentage passing through the number 10 sieve is 100%. Sieve number 40, 80%. Sieve number 200, 58%. And the liquid limit and plastic index of the minus number 40 fraction, these are respectively 30 and 10. It means liquid limit is 30 and plasticity index is 10. Okay, and the task is to classify the soil using the unified classification system. Okay, so I'm gonna put this here, just a summary of the percentage of passing of each sieve and the liquid limit and plasticity index. Okay, so I think you remember this table. We studied this table in the previous video. Okay, so according to this, the passing of sieve number 200, we have 58% passing the sieve number 200. And as we can see, this table is telling us if 50% or more is passing here, the sieve number 200, then the soil is fine-grained soil. Okay, so here we have 58. 58 is more than 50, right? So it means our soil is a fine-grained soil. So we will focus only on this second part of this table, okay, which is here. Now, let's go to the liquid limit and check if it is more than 50 or less than 50. As you can see, even the chart here, we have low plasticity here and high plasticity here. So in our case, the liquid limit is 30. So 30 is less than 50. So it means we are in this case. Okay. And as we can see here, the plasticity index fall right here. Our PI is 10. Plasticity index is 10. It means that we are in this case, the plasticity index is higher than 7. Okay, and it's saying us here higher than 7, and the plot is on or above line A. Then we have this one condition is validated already. The plasticity index is higher than 7 because it is 10. Then we can check if the plot will be above the line A or not. So if we try to plot this with this coordinate 30 and 10, 30 for liquid limit here and 10 as plasticity index. So I think the point will be here, the plot will be here, which is above the line A. This is the line A, okay? So it means we are in this case, exactly in this case. It means we are dealing with the group symbol Cl, okay, which is clay with low plasticity, okay? So now, if we want, do you remember this chart, the figure 5 of the previous video? We have talked about this in the previous video. So this is if we want to know, you remember that, just keep in mind that our soil is the symbol, the group symbol is Cl, okay? Clay with low plasticity. So if we want now to know the group name using this chart, then we have to follow these arrows. Last time I said there is nothing to explain about this. You have just to follow the arrows. So Cl is this, as you can see, which is actually when the liquid limit is less than 50, which is our case because our liquid limit is 30. Okay, so we have the group symbol Cl. So by following these arrows, we can find out what is the group name. It should be one of these because we are here. Okay, so let's go. But as we can see, for this we will need to know if maybe gravel or sand, the percentage of gravel and sand, compare if the percentage of sand is higher or smaller than percentage of gravel, or the sieve number, the passing of sieve number 200. Okay, so how do we know the percentage of gravel if it is smaller or higher than the one of sand? Okay, for that I need to remind you this table. Do you remember this table? Okay, this table is, I think, in the chapter number 2, or I have explained this table also in the previous video as well. So the classification, the unified classification system is saying that gravel is soil that has soil particle size between 76.2 to 4.75 millimeters. Okay, this is the range. So if we want to know the percentage, the amount of gravel, we should check what is the percentage retained by the sieve number 4, which is the opening 4.75. Okay, remember that. So if we check in our case, what is the amount, what is the percentage of the soil retained on the sieve, on the opening, on the sieve number 4, which is the size, opening size of gravel, the bottom limit of gravel size. Okay, so we have to check the amount of soil passing this sieve. Okay. If everything passes, if 100% passes, it means there is no gravel in the soil. Okay. So only the percentage that is retained on this sieve will be the percentage of gravel. But as you can see, the sieve number 10 itself, 100% is passing. Okay. So if we go back again, sorry, sieve number 10 is here, which is opening 2 millimeter. But in our case, even this sieve number 10, 100% of the soil has passed. It means that the soil particles are smaller than 2 millimeter. If they are smaller than 2 millimeter, it automatically means that they are also smaller than 4.75 as well. So in that case, the percentage of gravel we have is 0%. Okay, so it means that in our case, the percentage of gravel is smaller than the one of sand. But anyway, we have first to check the amount of the percentage of passing the sieve number 200. What is this percentage? It's saying 58%. So here is when the percentage is less than 30%, which is not our case actually. Here is our case. The percentage, sieve number 200. 200 is 30 or more. Okay. 30% or more than 30%. In our case, it's 58%. So it's more than 30%. So we are in this situation. And then we check what I was talking about right now. If the percentage of sand is higher than the one of gravel, or it is reverse case. In our case, the percentage of gravel is 0. So it means that we have the percentage of sand is higher than the one of gravel. Okay, because the percentage of sand is the 100% minus 80%. So which is 42. Okay, 42 is higher than 0. So it means we are in this case, the percentage of sand is larger than the one of gravel. Then we continue. Is the percentage of gravel, is it less than 50% or higher, larger than 50%? Not 50, sorry, 15%. Okay. Since it is 0, it means we are here. It's less than 15%. Then our case, less than 15%. Okay. So it means that our soil is this one, sandy, lean, clay. This is the group name. Okay. So you have the group symbol is CL. I think the group name now is, group symbol is CL. Okay. And the group name is sandy, lean, clay. So there are in some cases, some professors may ask you to just limit yourself the group symbol. Just here is enough for them. If you find the symbol CL, for example, it's enough for them. Okay, but don't forget that sometimes you will need double symbol in this classification, and we have explained all this last time. Okay, so I think for this example, that's all. Let's go to the next example, example number 2. So for this example, we have this particle size distribution curves for two soils, soil A and soil B. And we have here liquid limit and plastic limit, not plastic index, not plasticity index, plus liquid limit and plastic limit. Okay, so what we have to do is to determine the group symbol and group names, okay, according to unified soil classification system. So here we have to do both as well. Sometimes you don't have to do group name, okay, but sometimes you have to do both. But at least if you are asked to do group to give the group name, you have to do the group symbol, to obtain a group symbol first before doing the group name. Okay, you have no choice. Okay, let's try. I will try to do the for the soil A, and maybe for soil B you can do it by yourself. You can try. Okay, so when we check this soil, the sieve number 200, which is opening 0.075. Okay, so that one, the sieve number 200 is telling us that the percentage of soil passing is how much? Is it less or higher than 50%? So if we check here, we are dealing with the curve A, curve of the soil A, okay? Soil A. So if we check sieve number 200, what is passing here is very small, as we can see. If we can, this is 20, so 10 is maybe around here, maybe less than 10, I think. So the passing of sieve number 200 is 8. Okay, so that means that we are dealing with coarse-grained soil. Okay, not fine-grained soil, because the percentage passing the sieve number 200 is small. Or reversely, you can say the percentage retained on the sieve number 200 is more than 50%. Okay, this is what is written here. Coarse-grained soil. For coarse-grained soil, more than 50% of this of the soil is retained on the sieve number 200 sieve. Okay, so we are in this case. And then we try to check for the sieve number 4. Okay, sieve number 4, what is passing? Sieve number 4 is 0. So in that case, we are here. Okay, so just remember sieve number 4, what is the opening of sieve number 4? Because for sieve number 200, it's 0.075, which is here. You remember for the sieve number 4, which is for gravel, let me go back, okay, which is for gravel, it is this one, okay, 4.75. Okay, for this sieve number 4, as you can see on our curve, let's go back. there is no, the maximum here is 1 even. Okay, so 4, nothing is retained on the sieve number 4, because sieve number 4, which is 4 point something 75 millimeter, because here the maximum diameter is even 1. Okay, so it means even the opening 1 millimeter, everything has passed. So it means the soil has passed all the soil has passed the sieve number 4. It means that here more than 50% is passing the sieve number 4. Nothing is retained. Okay, retain on sieve number 4 is 0. So it means we are here in the sandy soil. Okay. Then we have to check these coefficient Cu and Cc, and see what are the value of these. Okay, so it is here actually, sieve number 4. We have here, you have it here. I forgot. Sieve number 4, which is opening 4.75. You see, the maximum opening here is 1. It means all this 100% has passed the 1 millimeter diameter. It means that 100% of the soil particles are smaller than the diameter 1 millimeter. So obviously they will also be smaller than the opening 4.75. It means everything is passing this sieve number. It means again, nothing is retained on this sieve. Okay, so the liquid limit and plastic limit are here for the soil. So we can check first Cu, the value of Cu and Cc. So for that, we have the formulas here. Okay, Cu, so D60, D10, we have all these value here. D10 is 10, this is 20, 10 is around here. So it is smaller than 0.1. So 0.085 here. Okay. D30, 30 is here, 40, 20, 30 is in the middle here. So if we project on the curve, maybe it will be around 0.12. Okay, around here, 0.12. D60 here, 60 here, we project on the curve, okay, and see how much it will be. So it is saying 0.135 millimeter. So after obtaining all these value, D10, D30, and D60, we can calculate this coefficient. Okay, Cu will be 1.59, which is smaller than 6. So we are here, smaller than 6. And Cc is 1.25, which is higher than 1. So smaller than 6. And this is higher than 1. So in this case, it means we have to check double symbol, the existence of double symbol. Okay. Now we can check the liquid limit and plasticity index. Liquid limit, which is 30, it is here, and plasticity index, which is liquid limit minus plastic limit. So 30 minus 22, it will be 8. Okay, so we'll have something maybe above the line A also, I think. Okay, so just remember something. Do you remember in which case we have double symbol for the coarse-grained soil? We have double symbol when the percentage of fine is between 5 and 12. Do you remember that? If it is less than 5, then we are dealing with clean sand. If it is here more than 12, then the sand, we have sand with fine. Okay, this is written here, sand with fine. Here is clean sand. But in our case, if we check what is the percentage of fine, the percentage of fine is just the percentage passing the sieve number 200. And for that, the sieve number 200 is, what is passing is 8. And 8 is exactly between 5 and 12. So it means we have to do the double symbol. Let me go back a little bit to show you what I'm talking about. Go back. It is here, I think. Okay, here. See, between, if you have gravel or sand with 5 to 12% fine, that requires double symbol. Okay, in our case, sand and the fine are between 5 and 12 because we are 8, we have 8%. So it means we have to use this double symbol. So in our case, which are the double symbols we have to use? Okay, let's go back. So because we are here, so it has to be this one, SP, not SW, because the CU is here. Our CU is less than 6. Okay, then we have to check now for the PI, the plasticity index. In our case is higher than 7, right? Because plasticity index is 8. So in that case, we are in this case, and we check plasticity index is higher than 5, higher than 7, then the plot is on or above the line A, because there are two conditions. So if we check 30 and 8, maybe it will be just on or above the line. Then I think we are in this case SC. That's why we have this double symbol, SP dash SC. Okay. And now if we want the name, if you want to determine the group name, okay, we have to refer to this figure 4. Okay. So the percentage of gravel, once again, for the gravel, it means 5 or 4.75. Okay. If anything is retained on the sieve number 4, that percentage, that amount will be the percentage of gravel. Okay. But in our case, there is no gravel, I think. So it is 0. But remember that the group symbol is here, SPSC. So since the group in symbol is SPSC, we are here, SPSC. Okay, it means it will be these two possibility, this or this possibility. And what will guide us is the percentage of gravel. Is the percentage of gravel, this is same, okay, what I put here, it's same. So the percentage of gravel is less than 15% because it is 0. Okay, that's why the group name will be poorly graded sand with clay, which is actually the group name here. Okay, SP means poorly graded sand and SC means sand with clay. So it will be here, this line, poorly graded sand with clay. Okay, or again, silty clay. I think that is the end for the example number 2 also. So let's go now for the next part, comparison between the AASHTO system and the unified classification system. What are the differences between these two systems? What we know is both these systems are based on size distribution, particle size distribution, which is structure, and also on plasticity of the soil, both of them. Okay, and also both are using the sieve number 200 to divide soil with two groups. Okay, two major category, which is coarse-grained soil and fine-grained soil. Both of them are using the sieve number 200 for that. But according to the AASHTO one, the soil is considered as fine-grained soil if more than 55% passes the sieve number, the reference sieve number 200. But on the contrary, the unified classification system, soil is considered as fine when 50%, more than 50% passes the sieve of reference, the sieve number 200. See, the percentage is high, I think. The difference is high. Okay, for the AASHTO system, if 30%, 35% passes, they are considering already that, okay, this amount of fine is too high. Okay, so, and in reality, if we check a coarse-grained soil that contain about 35% fine grain will behave more like fine-grained soil. And the reason for that is because the enough fine grain exists to fill the void between the coarse-grained soil. And because of that, we can consider that the AASHTO system is here more appropriate, because the AASHTO system is considering that once the percentage of fine are more than 55%, they consider that it is fine-grained soil. And another thing is ASTO system is choosing sieve numbers 10 sieve as the sieve to separate gravel and sand. However, as we have seen now, for the unified system, this separation is made using the number 4 sieve. Okay, so and the number 10 sieve is also more accepted after upper limit of sand for sand. So this limit is used in concrete and highway-based coarse technology. Let's continue still with the differences. So the unified system, in this system, unified system, we have very specific names. The names are very clear, very a lot of different type of soil name. For example, sandy soil and gravelly soil. These two are clearly separated in the unified classification system. However, if you go in AASHTO, there is no big difference between sandy soil and clay and gravelly soil. They are not separated. If you see in the AASHTO system, the A2 group contain large variety of soil, a lot of variety of soil, which is well separated in the unified classification system. So in the unified classification system, we have all these symbols: well-graded gravel, silty sand, I think, clay with high plasticity, this kind of symbols, and many other used in this unified system. They describe more the soil, the type of soil, more than the AASHTO system. The AASHTO system is just using this, the only one symbol used in AASHTO system is A1, A2, A3, up to A7, okay? However, in the unified system, there are more detailed, it describes more the soil, okay, as we can see here. Okay. Again, for the organic fine soil, classification of organic soil, we have organic clay or silt with low plasticity, organic soil with high plasticity, and peat also. These are in the unified classification system, but we cannot find these in the AASHTO system, okay? So this AASHTO system, there is no place for this organic soil. This is also a disadvantage of this AASHTO system in this case. So we have usually peat are high moisture content, low specific gravity, and low unit weight. And we have here a figure showing scanning electron micrographs of some pits, four pits with the name. I think these names are depending on the place where we can find this pit. Fondilac pit. Fondilac, that one is in French. Portage pit. I don't know where this one. Middleton pit. Where is this one? I don't know. So maybe name of city somewhere. I'm lazy to check this. Yeah, anyway, this table is giving the parameter of these pits. Okay. 4, 1, 2, 3, 4. Same here, 1, 2, 3, 4. The moisture content, As you can see, it's very high. Okay, more than 100%. Okay, unit weight, very low unit weight. Specific gravity also. Earth content. And this reference did comparison between the two systems, AASHTO system and unified classification system, in these two tables. This first table, this is more like correspondence between the group symbols. Okay, for example, if you take the AASHTO system, the A1A AASHTO system soil group symbol, maybe we can call it group symbol also. It is the most appropriate corresponding group symbol in unified classification system is this: well-graded gravel and poorly graded gravel. And the possible classification are this: sand, well-graded sand and poorly graded sand. Here, these are possible, but as you can see here, improbable. Okay, the probability is very low for this. Okay, so silty gravel or silty sand. So as you can see here, for each symbol group, each soil in AASHTO, this table is giving the most possible correspondence in the unified classification system. This is most probable one, the possible one, and possible but improbable one. Okay, you can check later. This figure also, this table, sorry, is also comparing same. As we can see here, these are the group symbol for unified classification system and correspondence in AASHTO system. Most probable, possible but improbable. Okay. Okay, I think we will stop here, and that will be the end of this chapter. Okay. So next time we'll start a new chapter, chapter number 6. Thank you very much for your time.